This video is in the unit on polynomial functions. We are going to look at degree, what is it, and what can it tell us about the polynomial function. In the past, if you've talked about the degree of something, you maybe were talking about temperature. Or maybe you were talking about deodorant. Okay, bad attempt at math humor. Not really math humor, just, trying to do a math video and make it interesting. Or maybe you're talking about measuring an angle, and that is measured in degrees. What we're talking about today is a whole different thing. The degree of a polynomial is its largest exponent. And that is if it is unfactored. If you're not sure what that is, we'll talk about it. If it is in its factored form, you want to count the variables. When we look at examples, you'll see what I'm talking about here. Our first function, h of x, is not factored. Not factored. So we look to see what is the largest exponent of this, and it is the 4. So this function is degree 4. Here's another function that is not factored. You have to look for the largest exponent. Were you thinking 5? Take a second look. They're trying to be tricky here. The largest exponent, or the term with the largest exponent, may not always be in the front. In this case, this is the term with the largest exponent, which means this function is a degree 7. All right, this g of x, this is an example of a function in factored form. Factors are things you multiply together. So factored form means two things multiplied together. So in that case, we count the variables. We have 2 variables, which means this is degree 2. This is another factored function, so we will count the variables. We've got 1, 2, 3. So this would be degree 3. And you count the variables, because if we would multiply this all out, our leading term would be an x cubed. If we multiplied these all out, it would, or an x, this would be an x squared, excuse me. This is an x cubed. So let's see now, what does this mean as far as polynomial functions? We can tell if a function is even or odd. And the easiest thing is, if the degree is an even number, you have an even function. If the degree is odd, you have an odd function. Even or odd tells you what will happen at the ends of the graph. In other words, the long run behavior. For example, in h of x, this is an even function. The ends are here. This is what we're talking about with the ends of the graph. And in this case, they're both going in the same direction. F of x is a degree 5, so it's an odd function. We look at the ends, we see they are going in opposite directions. G of x was degree 2, even function. they're going in the same direction. The p of x was an odd degree, and they go in opposite directions. This is long-run behavior. They may express it as x goes to positive infinity, meaning as x gets larger and larger and larger, what is happening to my graph? In this case, h of x is also going to positive infinity, if we were looking at this example. For the f of x, as x approaches infinity, so we look up going to the right, what's happening at the end of the graph? It's going down towards the negative. F of x is approaching negative infinity. So even and odd tell you what's happening on the ends of the graph. Even functions, the ends of the graph are going in the same direction. Odd functions, they're going in opposite directions. But what about, look at this one. These are both odd functions, but they're looking different there. Let's look at better graphs here. So this one is going up, and then it's going down. This one starts off going down, but then it ends going up. What is the difference with these two odd degree functions? Why one of them, as x goes to infinity, this function, f of x, goes to negative infinity, and as x goes to infinity, this particular function is going to positive infinity. It has to do with the leading coefficient. The leading coefficient is in the term with the largest exponent. In f of x, this is my term with the largest exponent, and that means -2 is my leading coefficient. In this example, you're like, well, wait a minute, it's not multiplied out. Just look at what's the sign going on in the front here. Look for that sign. There's nothing written there, so we know automatically that means positive. So with a positive leading coefficient, the end of your graph goes to positive infinity. If it has a negative leading coefficient, the end of your graph is going to negative infinity.